Hey guys, first video about complex fractions. I'm going to try and do this one with the drawing tablet, see how that goes. So let me share that with you so you can see what I'm doing. And if we don't like this way, I'll switch back to do it on the whiteboard, but it's up to you guys a little bit. So complex rational expressions, when I talk about that, there's something just called complex fractions. And basically, it's when you have a fraction inside of another fraction. So you can see here, this expression is like a big fraction bar with the two smaller fraction bars below it. Sorry, the two fractions at the top and two fractions at the bottom. These ones are added, these are subtracted, whatever. So there's two ways to do this. I'm going to show you both, but I'm going to use the second one pretty much exclusively. So the first way is you add these together, and then you add these together. Technically, you subtract those, and then you divide the two fractions you'll end up with. So to add fractions, we got to find a common denominator, which in this fraction on top is going to be 4. Least common denominator of 2 and 4 is 4. So it's like 2 over 4 plus 3 over 4. On top, the bottom, the least LCD of 6 and 8 is 24. That's 20 over 24 plus, it's not plus, it's minus, isn't it? Minus, and then 3 over 8 is 9/24. So on the top, we get 5 over 4. And on the bottom, we get 11 over 24. And then now that we have just one fraction divided by one fraction, we can do our keep, change, flip, or multiply by the reciprocal. 5/4 times 24 over 11, which is, I mean, you can cross cancel or something maybe. That's a 1, and that's a 6. So I get 30 over 11. So this is one way to do this. You like add or subtract whatever's happened on the top and bottom of the fraction. That's what I did here. And then you divide, which means you multiply the reciprocal, and then you cancel or simplify as much as possible. This is what is called method 1, and it's not the way that I like to do it. I like to use old method 2, classic method 2. For method 2, you got to find the LCD of all the terms of every fraction in there. And then you multiply the top and bottom of the fraction by that LCD. So I'm going to look for the LCD. There's 4 terms here: 1/2, 3/4, 5/6, and 3/8. All have different denominators. I got to find the LCD of 2, 4, 6, and 8. You can maybe see that the LCD of 2, 4, and 8 has to be 8, because the LCD has to be at least 8, and 4 goes into 8, and 2 goes into 8. So really what I want is the LCD of 8 and 6, which is 24. We saw that last time. So instead of like rewriting all of these things as fractions over 24 and then dividing, I'm just going to do this. I'm going to multiply. Got to get back on the pen. I'm going to multiply this fraction here by 24 over 24. What happens is I like distribute the 24 to each one of these terms. And what ends up happening is the fractions disappear. 1/2 times 24 is 12. 3/4 times 24, well, I could do the dividing first and the multiplying. 24 divided by 4 is 6. 3 times 6 is 18. There's a plus in between those. Then underneath it, I do 24 times 5, 6. So 24 divided by 6 is 4. 4 times 5 is 20. Then 24 divided by 8 is 3, and 3 times 3 is 9. So that's 30 over 11. And this is the same answer as we got before, but to me, this is a much easier way to do this. When we start simplifying complex fractions that aren't just numbers, it's going to be way easier to do it this way. So this is our first example without numbers. You can see it's a complex fraction. There's something plus something on top and something minus something on the bottom. The adding and subtracting doesn't really make any difference. Just know that this is a complex fraction because it's got fractions in fractions. So the way I'm going to do these every time is to find the least common denominator of all the fractions in the complex fraction, then multiply the top and bottom by that. So I've got 4 terms. I'll list them over here, but I probably wouldn't normally do this every time. A cubed b, b, a squared, b squared, and b squared. These are all the denominators of all of these fractions over here. A cubed b, b, a squared, b squared, and b squared. Now I use these to build my LCD like we did before, and then I'm just going to multiply the top and bottom of this whole complex fraction by that LCD. So I need 3 A's at least, because there's 3 A's in that one. I don't need any more. This has no A's, that has 2 A's, that has none. The largest number of 0, 2, 0, and 3 is 3. 1B, 1B, 2 B's, 2 B's. That means I need 2 B's. I think that covers everything. 1B is already in there, 2 and 2 is already in there, 2 B's is already in there. So this is my LCD right here for all the fractions. Now I'm going to do multiply by a cubed b squared on top, multiply by a cubed b squared on the bottom, and this is going to give me an equivalent fraction to this that's going to be much easier to deal with. So if I multiply a cubed b squared by this term, the a cubes and the a cubes, like this a cubed is like a cubed b squared over 1. It's like a cubed b squared over 1. And like what that means is that I multiply this by the top, and I'm going to cancel out whatever common terms are on the top and bottom. I'm going to write out this whole step here, but I probably wouldn't normally do this. A cubed b squared over a cubed b plus a cubed b squared over b. A cubed b squared over a squared b squared. A squared over b squared. Now I can cancel out all my terms. Remember, when I do this, I distribute, I distribute this term to both of the things that are added and distribute this one to both things that are subtracted. I end up with all of these. It's kind of a big mess here, but it's going to simplify a bit. Let's see. Here I can cancel out the a cubed and 1b on the bottom and 1b on top, leaving 1b on top. Here I can cancel out 1 and 1 plus a cubed b. Here I can cancel out both the b's on top and bottom, 2 a's and 2 a's, leaves me 1a. And then these are both b squareds. What's a minus a cubed? This probably has a little more factoring that can be done, but for now I just want to stop here. I might come back and finish that later, but this can be factored more. I can see that I'm going to get a times a minus a times 1 minus a squared on the bottom, but we can worry about that later. Just know here the best way to simplify these is find the LCD of all the fractions in the complex fraction, and then multiply everything top and bottom by that LCD. And what happens is all the fractions go away, and now I'm down to a regular non-complex fraction. So keep an eye out for the next video. This one's gotten pretty long, and we will finish this up then.